I made a promise last week, and now I'm going to fulfill it. Today, we're finally going to talk about supervolcanoes. Not only that, we'll talk about the Ring of Fire and some of the most amazing and influential fossils that were created by volcanoes. A supervolcano is defined as a volcano with a VEI of 8, the highest possible score. There are about 20 supervolcanoes known worldwide, the largest of which being the Yellowstone caldera. The most recent supervolcanic eruption was that of Taupo in northern New Zealand around 27,000 years ago. Supervolcanoes have especially large calderas from their extremely violent eruptions in the past. According to National Geographic, a caldera is a large depression that forms when a volcano collapses from a violent eruption. Yellowstone's caldera is 50 miles long and 40 miles wide. The eruption that created this caldera happened around 631,000 years ago. That gives you the sheer scale of a supervolcano's eruption. Yellowstone's eruption created a crater larger than the US state of Rhode Island. To calculate the area of the crater, let's say the Yellowstone caldera is a perfect oval. It obviously isn't, but let's just pretend it is. In that case, we would plug these values into the equation for the area of an oval and get a rough estimate of the crater's surface area, which is roughly 1,570 miles squared. However, only after I'd done this calculation did I realize that the National Park Service literally has the area of the caldera measured as 30 miles by 45 miles, putting its area at 1,350 miles squared. Speaking of the Yellowstone caldera, if super eruption happened, which is not expected for the next 1,000 years, it would greatly affect the global climate, as well as spread a blanket of ash all over the North American continent. The Ring of Fire isn't the name of some fantasy book series, it's a real region of the planet. The Pacific Ring of Fire is a connected string of islands and ocean that displays high seismic and volcanic activity. In fact, 90% of earthquakes happen there, and 75% of Earth's active volcanoes are there. The string stretches from southern Chile to the Pacific Northwest to Japan, through the Pacific Islands, and finally ends in New Zealand. It exists due to being situated over many tectonic plate interactions. The Pacific Plate interacts with the North American Plate, the Eurasian Plate, the Filipino Plate, and the Australian Plate. In the Americas, the Nazca Plate interacts with the South American Plate, the Juan de Fuca Plate interacts with the North American Plate, and the Cocos Plate interacts with the Caribbean Plate. That's a total of 7 interactions in this relatively small region. I really like this map because it shows the types of interactions between each plate. For instance, many plates in the Ring of Fire are pushing into each other, which is why their volcanoes are active. California gets so many earthquakes because the Pacific and North American plates slide against each other. Around 12 million years ago, Yellowstone erupted. Being a super eruption, the ash was sent thousands of miles away, potentially even to the Atlantic Ocean. Some of the ash reached a riverbed in Nebraska and slowly began to kill all the animals living there. In the end, all the animals died and were covered in a blanket of ash. All of this fossilized, creating what we know today as the ashfall fossil beds in Nebraska. These animals, from birds to rhinos, were so well preserved that we now know that the rhinos lived in herds, something we would not have been sure of if they didn't all die together. There were unborn fetuses that were also impeccably preserved. The reason for the amazing preservation was because the ash blanketed over the remains protected them from erosion. I'll leave you with pictures of the fossils. This is it for the volcano series. Now I'm gonna have to think of another topic. You know what? Leave some suggestions in the comments and I might do them. It'll certainly make my job easier. I'll see you next week.